Hello and welcome to my channel. In this video we are going to solve some examples to find the domain and range of the trigonometric functions. And in this video we are going to cover mainly three main trigonometric functions, that is sine, cosine and tangent functions. So here we are going to solve three examples, that is one on sine, one on cosine and one on tangent. But before we can start solving those examples, let us understand what are the domains and ranges of these three functions. Now here you can see that I have made a table, and in the table you can find all the three trigonometric functions, that is sine, cosine and tangent, and their respective graphs, the domains and the ranges are being mentioned. Now first of all, let us understand what do you mean by the domain and the range. Now domain represents all the x values on which the trigonometric function is drawn. Now for the sine trigonometric function, this graph exists for all the real numbers which are present on the x-axis. So the real numbers can be integers, decimals, fractions, square roots, cube roots, everything will fall under the domain of the sine trigonometric function. So you can see on the x-axis we have 0, we have pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi and so on. And same thing repeats on the left negative x-axis. Now let us come to the range. Now the range represents all the y values of the sine trigonometric function. And if we look carefully, the maximum value the sine function can reach is positive 1. And the minimum range it can drop down to is negative 1. So it will again move on to plus 1 and then negative 1. So it is toggling between positive 1 and negative 1, and it keeps on repeating for every period of 2 pi. That is, from 0 to 2 pi you can see there is one wave. And again from 2 pi to 4 pi there is going to be another wave. Same thing repeats on the left negative x-axis. So the range is from negative 1 till positive 1, and the period of a sine function is 2 pi. Now let us come to the cosine trigonometric function. Now for the cosine also, the domain, that is the x-axis, is all real numbers. That is, this graph exists for all the real numbers which are there on the x-axis. And similar to the range of the sine, we can see that it toggles between negative 1 and positive 1. So the minimum value it can reach is negative 1 and the maximum value it can reach is positive 1. But there is a major difference between the sine and the cosine curve, because you can see that the sine curve starts at 0 but the cosine starts at positive 1. So there is a phase difference of pi over 2 between the sine and the cosine curve if we overlap this graph of cosine on the graph of sine. So here mainly for these examples we need to remember the domain and range of the given trigonometric functions. Now for sine and cosine, they both are same. Now let us look at the last trigonometric function which we are going to discuss, that is tangent. Now here you can see the graph of tangent. It is a curve which resembles the shape of a S, and here we have drawn dotted lines as you can see. Now what does it mean? The domain or the x-axis on which the tangent function can exist is all real numbers except x should not be equal to plus or minus 2n plus 1 pi over 2. You have to remember this because it is going to be useful in solving the examples. Now this means that at every odd multiple of pi over 2, there is going to be an asymptote. These dotted lines are called as asymptotes. And the tangent function, you can see it exists for anything in between the asymptotes, but it cannot touch the asymptotes. So it keeps on going parallel to the asymptotes as long as possible. They are never going to meet each other. And the range or the y-axis of the tangent is all real numbers. So all real numbers we can also write it as from negative infinity till positive infinity. So this also can be represented over here, that is all real numbers are from minus infinity to plus infinity. That is, it has no end. It starts at negative infinity and it can go till positive infinity. That is, in case of tangent, the range is all real numbers. But in case of sine and cosine, the domain is going to be all real numbers. So here also we can write minus infinity to plus infinity. So make sure you have learnt the domain and ranges of sine, cosine and tangent, because we are going to make use of these concepts to start solving the examples now. So find the domain and range of the trigonometric functions. The first one is y is equal to -2 cos x minus 3 plus 1. Now we can clearly see that this is a cosine trigonometric function. So let us start by writing its domain. So it is a cosine trigonometric function, and domain, as we have seen, it's all real numbers. Now let me write down the range, and here there are three ways of representing the range. So the first way of representing the y-axis or the range of the cosine function is -1 is less than or equal to y is less than or equal to 1. As we saw, it toggles between maximum of 1 and minimum of -1. So this is the first way of representing it. The second way is -1 is less than or equal to f of x. Now remember that another way of writing y is f of x. So in place of y, we have just put f of x is less than or equal to 1. And the third way of representing it is -1 is less than or equal to cos x is less than or equal to 1. Now for these kind of questions, the last representation is easier to use and solve the example. So let me use the third representation. Now let us start solving to find the range of this function. So in place of cos x, we are going to write cos of x minus 3. So remember to start solving from inside out. So take the inside bracket x minus 3, then we can start multiplying this cos x minus 3 with -2. So I'm going to write here. So -1 is less than equal to cos x minus 3 is less than or equal to 1. Now we are going to multiply -2 to the cos x minus 3. Now since the cos is getting multiplied with -2, we have to multiply the entire range by -2. So let me write here. So you can see we have multiplied -2 to all the three given elements. Next, let us simplify this. So -2 times -1 gives us 2 is less than or equal to -2 times cos of x minus 3 is less than or equal to -2 times 1 is -2. Now whenever we are writing an inequality, we have to always write the smaller number on the left hand side and the bigger number on the right hand side. Since -2 is a smaller number and 2 is a bigger number, we are going to swap their places. So 2 comes over here and -2 comes over here. So let me rewrite it. So we have here -2 is less than or equal to -2 cos of x minus 3 is less than or equal to 2. So we have swapped the places. Next, let us come back to this. Now we have +1 to be added to -2 cos of x minus 3. So now again when we are doing this, we have to do it for the entire range. So here -2 plus 1, -2 cos x minus 3 plus 1 and 2 plus 1. So let me write here. Now the next thing is just simplification. That is -2 plus 1 gives us -1 is less than or equal to. Now this entire thing represents the range which was given as a question. So in place of this, I'm going to write simply y is less than or equal to 2 plus 1 is 3. So the range of our function is going to be from -1 till 3. So this is the way we have to solve it, and solve it step by step to get the correct range. Now let us look at the second question. Now in the second question, we have to again find the domain and range of the tan trigonometric function, as we can see. So the question is y is equal to -2 tan 3x plus 1 plus 4. So let us start by writing its domain first. So its domain of the x is given as x should not be equal to plus or minus 2n plus 1 pi over 2, where n is 0, 1, 2 and so on. Now here, since the domain is asked, we are going to concentrate on the given x value for the tan, that is 3x plus 1. So we are going to equate 3x plus 1 to 2n plus 1 pi over 2. So let me write here. So we have equated 3x plus 1 in place of x should not be equal to plus or minus 2n plus 1 pi over 2. Now simply we have to start solving for x. So we are going to take the plus 1 on the other side of the equal to sign. So we get 3x is not equal to plus or minus 2n plus 1 times pi over 2, and this plus 1 going on the other side becomes minus 1. So let us take the LCM here. This is 1 over 1. This is 2 times 2. So we are going to get on the right hand side, this should not be equal to plus or minus 2n plus 1 times pi, and this 1 multiplies with 2, so we get minus 2 over, now we get a common denominator of 2. So 3x should not be equal to this value. So taking 3 on the other side, we can write x should not be equal to plus or minus 2n plus 1 times pi minus 2 over, this 2 multiplies with 3 giving us 6. So the domain of this tan function is going to be all real numbers except x equal to plus minus 2n plus 1 times pi minus 2 over 6. So let me write here, domain is all real numbers except the calculated value. Now we have to find out the range of the given trigonometric function, and we know that the range of the tangent function is all real numbers. So we are going to simply write here that the range is all real numbers. Now let us move on to the last question. Now the last question is on sine trigonometric function. So let us begin by writing its domain first. So the domain is given as all real numbers. So let us now find out what is the range of the given function. Now for the range, I have used the third type of representation, that is minus 1 is less than or equal to sine x is less than or equal to 1. Now to solve this, we are going to simply replace x with x minus 2, and this is a horizontal translation, so it will not affect the range values. So let me write it. So you can see the range is not affected when we replace x by x minus 2. Now the final term, that is plus 8. Now the 8 is added to the sine function and it changes our range. So we are going to add the 8 to all the three terms. So minus 1 plus 8 is less than or equal to sine x minus 2 plus 8 is less than or equal to 1 plus 8. Now we can see the range is affected. So simplifying this, we'll get minus 1 plus 8 is 7 is less than or equal to. Now sine x minus 2 plus 8 is nothing but your f of x, which is the range. So writing here f of x is less than or equal to 1 plus 8 is 9. So this is the range of the given function. So if you want to visualize it, for example, the curve reaches maximum till 9 and reaches minimum till 7. So its minimum value is 7 and its maximum value is 9. And this is on the y-axis. So I hope you have understood all the steps and liked the video. If you have any doubts or questions, do comment below. And if you are liking my videos, like, share and subscribe to my channel. And thank you for watching.